Hello and welcome back to Calculus 1, section 3.10, derivatives of inverse trigonometric functions. So now we know that inverse of the sine is, and inverse of and the derivative of tangent is secant squared x, and the derivative of cotangent x, negative cosecant squared. Good. So now, if you remember from your pre-calculus or trig course, you had that y is equal to, let's say, sine x, where x was the angle, which is the input, and y is the number, also known as ratio, which is the output. So you will say that sine of, let's say, pi over 6 is equal to 1/2. Now pi over 6 in radians. You can also say sine of 30 degrees is equal to 1/2, in which case now this is in degrees. So we can loosely write that sine of the angle is equal to a number. Now remember what inverse does. Inverse swaps domain and range, which means that the sine inverse of a number must be the angle. So as an example here, I write sine of 1/2 is equal to pi over 6, which is 30 degrees. So the input in the inverse sine of 1/2 is pi over 6, or 30 degrees. So the input is the ratio and the output is the number. Now this leads us to understanding that sine of inverse sine of x, they actually cancel out and you just get x, because inverse of the inverse is the original thing. Think about it. You take a sweater, you invert the sweater, and then you invert the sweater again, you go back to the right face up, right? So a little bit trickier problems are the ones where you have these not matching, but you are not going to run into those problems all the way till differential equations. So you don't have to worry about remembering how to deal right now, how to deal with a problem that says cosine of inverse sine of x, blah, blah, blah. You utilize a triangle to deal with those. So those eventually pop up, and if you don't remember them from your trig course, you could review that if you want to. Now the goal for this lecture is, now that we recall our inverse functions and what they do. So as I said, you have a function, the sine of the angle is the number, inverse sine will be inverse sine of a number, gives you the angle. So it undoes the previous calculation. So now we are going to take a look at the derivative of each one of these, because I can create y equals inverse sine of x, and that's a function, because we were on the restricted domain and all of that stuff. So it is a function, and because this is a function, I can figure out the derivative. And as I said earlier, the derivation for these are in the textbook if you're interested to look up. Again, this is not an honors section, so we're not proving any of these things. You will need to learn these formulas to solve problems. Pay special close attention to inverse sine and inverse tangent, because those formulas will be back over and over in your future courses, like Calc 2, for instance, or Calc 3, or differential equations, if you are a math major. or engineering major. You have to take them all. So here are the formulas. Ready? We start with the derivative of inverse sine of x. And that's going to be 1 over square root of 1 minus x squared. What do you mean? Yeah. That's for tangent. We'll get there. So now the next one is the derivative of inverse tangent. And as I said, guys, pay close attention to these two formulas. They're very, very important and they show up all the time. And the third one in this category is going to be secant inverse, which is going to give us 1 over absolute value of x square root of x squared minus 1. So these are the 3. And now the other 3, the co-inverses, right? The cosine, cotangent, and cosecant, they have the same formulas with negative signs. This is why it's so easy to actually remember all of these, right? So the derivative of cosine inverse of x is just negative 1 over square root of 1 minus x squared. So it's just this negative that it's different between sine and cosine. The cotangent, same thing. It's negative 1 over 1 plus x squared. So it's the same. This, just put the minus in front. And finally, we have the cosecant inverse x, which is going to be negative 1 over absolute x divided times x squared minus 1. So I'll put this on a cloud. These are your formulas for 310. But we need to do better. We need to do better because this is only x. We need to redo these formulas for f of x because your question is not going to be what's the inverse tangent of x. It's going to be what's inverse tangent of e to the x. What's inverse tangent of x squared plus 7. Because those are the questions, right? Now, the trick is to replace this x with f of x. Then replace every x in the answer with f of x. And don't forget to do the chain rule, which means times f prime of x. So to give you a template, I'll do 2 formulas. The derivative of sine inverse of f of x. So this is what you are going to use 99% of the time. When it's not x, it's just some function there. And that is going to be f prime of x divided by 1 minus f prime of x squared. F of x squared. That's what it is. So every x is replaced with f of x, and then you are multiplying by f prime as a chain rule. So this is the formula which you are using 99% of the time. Here's another one. This is also a very important formula. It's the inverse tangent for the function, and you have f prime of x divided by 1 plus f squared. So you will be using these formulas most of the time. The only thing that it's left is for us to do examples and we're done. There's nothing much here. So what is the derivative of cosine inverse of, let's say, x cubed? What should I write as the answer? Yes?
Negative 3x squared over root 1 minus x to the 6.
Perfect. Perfect. This is your f prime on top, and the bottom square root of 1 minus f squared. Very good. So I'm going to find few exercises in the textbook. All right, so give me the, we'll do 2 from here. So give me the number from 15 to 30. 17. ddz of cotangent inverse square root of z. That's your 17. So what should I write here for the cotangent? Negative 1 over 2 root z. Okay, over. We have 1 plus z. This good? Now we're going to just do a little bit of algebra here. So this is over 1, double fraction. So we have negative 1 divided by 2 root z times 1 plus z. If you want to simplify a little bit. All right, cool. Give me one more number from 15 to 30. 23. It's also cotangent, something else. What happened? 28? Ooh, 28. Okay. There you go. (28) Sine of inverse tangent of ln x. Good choice, good choice. It's a little bit of a chain rule, right? It's a nested chain rule, just 3 steps. What's the main function? Sine. What's the next one? Inverse tangent. And the one in the middle is
No, I got a trick. What happened? I got a trick. So you like put your fingers on anything inside the press, and whatever's outside of that is the outside. Yes.
Everything else.
Not bad, right? Yeah, that means the sine will be your outer assumption. Remember our last class was having trouble today? How's that, right?
That's normal, but that's how that's the progress. That's the part where you learn. Because if everyone knew Calc 1 when they were born, we would not have Calc 1 class.
You didn't have a job.
Oh, I would not graph. I would do this.
What? You wouldn't do this? What would you do if you weren't doing this?
Probably be electrician.
There you go.
Or just Calc 2.
Just cool.
Or just Calc 2.
Or just Calc 2.
Just Calc 2, yeah. But you'd be teaching Calc 2 for like third graders.
If you wasn't doing this, you'd be working a lot of muscle.
Yeah.
Electrician.
There are kids where we must go. Have to learn something.
That's kind of interesting that you realize that Einstein was sitting in someone's classroom,
I wonder who.
and Tesla was sitting in someone's classroom, and Bill Gates was sitting in someone's classroom.
Probably with a
Their teachers, I think, are like the best.
Yeah. Shakespeare went to someone's English class and sat there.
Like, probably screwed off.
I hated Shakespeare for that. Like in history class, I was like,
Fine.
All the people that
Achieved some insane feat, they sat in someone's classroom.
Some of them got
We all learned everything.
Exactly.
Imagine teaching, like, hearing about Bill Gates, like, can I teach him computer programming this year?
oh my god.
Yeah.
I'm just figuring it out.
Yes, the problem starts with cosine. Good. There we go. That's the first.
That's like 1 point on the test.
It is.
Right? Just write cosine.
Start with cosine. It's
All I know is Benji's.
1.
You know.
1
So
Apparently I did that. I was thinking that just get rid of
This is the hardest, bro. Oh, no, he's gonna give us one. Yeah, I don't believe hundreds.
Yeah, it's like, wait.
No, we got it. We get it. So I always think that.
It's much more
It's like
than that. People don't realize my research shows that it's about 20 points more. Because you learn more, you learn every day for a week before the test, which prevents you from wasting 7 hours in the day before the test. Over the part of the room. 35 again, that's overcome the problems that you can during the course and just test it. And it's every day. So the courses you do it every day. So your base, knowledge base is higher, which means your base grade will be larger than before without the quizzes, because you learned them, and then you have plus 7. So that's why the span is about 20 points. I take the average of all the students who take quizzes, but I only take students who take 5, 6, or 7 quizzes. And then on the low end, I take students who take 0, 1, or 2 quizzes, along with, right? And when I do the average grade, I can go to the low end. So students who took 3 or 4 quizzes, I don't count them anymore. Because they usually stay. Now, I always have the outlier, the students who are so good that they don't want to bother with quizzes. Students score 90. Because normally quizzes is not not going to hurt you.
I only have one in the line.
But it can benefit only.
And then more than one, right?
He smokes cigarettes and
Yeah.
he drinks coffee. He has like it's like a snack.
Because plus seven doesn't mean waste of your own, but because coupled with the knowledge of doing it, it's equivalent to great. So I'm very happy with my. When I thought I was driving actually, and I pulled over. That's
I'm really
yeah, Calculus 7.
All right, so it looks like you have solved this, so I'm just going to write it out. So the main function is sine, derivative of sine is cosine, so we start with the cosine, and we copy everything else. That's the chain rule. ln. Can't write ln anymore. I guess we have to end class. Times the derivative of the inside, well, that's ln, which means that's inverse tangent, which means 1 plus function squared and then derivative of the function on top, times the derivative of ln x, which is another 1 over x. Oh, no, there's no, that's it. Sorry, that's it. That's it. So, again, over 1, that multiplies the 1 on the top. So what we get as the final answer here is we have cosine of inverse tangent of ln x divided by x times 1 plus ln squared x. And that's it. Well, let me just give you a preview of a Calculus 2.
Okay.
Is that fair? Look at this.
But that was easy. I already don't know what to do.
Calculus is the same thing, right?
It's a lot different.
There's a Calc 2 problem.
You just have to derive it again.
Same thing, it's just backwards.
You just derive it again.
No, this is integral. So,
Backwards?
so if you don't know how to go forward, then how are you gonna go backwards, right? That's the only place when I've seen that successfully done is with 0-year-olds. Okay, when they learn how to crawl, some of them actually learn how to crawl backwards first, and then they learn how to go forward. So that's that was him. Okay. So yeah, that's the scope. You have to know this in order to go the other way. All right, guys, one more problem for this section, and then let's do some lab. You're gonna love this one because it's really chapter 3 question. Yes.
What do you mean some lab?
Lab 2.
So I don't think we all went to hand lab 2, right?
No, we didn't, but that means you are still doing it, right? You agreed, then you will be handing it in. All right, one more problem, guys. Let's see. Oh, you're gonna love this one. So 34. This is it. Find the equation of what? That's it. Tangent line at the point ln2 comma pi over 3. Look at the point. Point is wonderful. For the function f of x equals secant inverse of e to the x. Yeah, Chewbacca, let's go. Yeah, it sounded like that, right?
It's like it was home tonight.
So it sounds like after you do too much calculus, right?
Oh yeah. right? Every day, all day. And you're happy about it too. It's what calculus creates emotions. Kind of
And anger. Despair. Yes. They just manage. You know how it is when you have wires on anything, they just kind of magically. That's why I believe it is the greatest.
you can buy them.
You thought I was with Rachel. Oh no, it was me. It was the funniest thing, right? No. And I hated it, right? Because she didn't want me to say anything because I felt very jealous person. So what I know I love Raphael. Anyway, so
You guys are not makes you sound more intelligent.
I've never.
Exactly.
Yeah, that's
You said that was for like 2 days, and then if you think this will be out of
I think I'm rubbing off on him though. Like, he's just gonna start saying no, we bonded over laughing at this. Yeah, yeah.
You don't know. You might have the ones that are sitting credit card. Right now.
I want to show you credit cards.
They get so much better because they're filming it. Like,
I'll tell you this much. I will.
I feel like the nursing students are the reason.
no, that is bad. You want to owe a lot of money.
That's mine.
You want to owe a lot of money and then pay it back. Just like with your credit card. Your credit card has $1,000. Right? You don't even know like 50 grand, right? If your credit card,
Yeah, pretty much.
Yeah.
How's the tangent line going? You're all different.
it
starts
with 2.
Professor, look, class has no idea, but tonight I'll look at it tomorrow and then I'll come to class. That's how I am.
I literally have no idea.
Tangents and secret squared excellence. I'll be ready by the test though.
I've seen them talk, I've seen their classes. It's not
He's not happy.
Okay, so it goes nursing, hairdressing, waitressing, board. And then you throw in babysitting or something. That is a scale.
That's 1 point.
And then pre-med is like up in the stratosphere.
Here. You want to utilize your credit utilization.
All right, let's talk about this and then transition into the lab. So we know that for the tangent line, we have to establish, well, we first have to find the slope, which means we need the derivative. So what's the derivative of this function?
What?
Yeah, what is it? It's going to be the absolute value, right?
Yeah.
Times what?
1
and then the derivative of e to the x goes up there, and then these guys cancel, so the whole thing is 1 over square root of 1 minus e to the x. Slope m is going to be, when we compute this, at ln 2. So what do we have at ln 2? You need to square this, right? It's e to the x squared, so 2x minus 1. So what do we get? Slope m is the derivative computed at ln 2. So that's going to be 1 over square root of e to the 2 times ln 2 minus 1, which is 1 over, now this goes as a square, so 2 squared is 4, ln cancels, so it's square root of 4 minus 1, which is 1 over root 3. So that's the slope, 1 over root 3. So now we have m, we have x, we have y. So y equal mx plus b. Y is pi over 3. M is 1 over root 3. X is ln 2 plus b. Wonderful, right? So b is pi over 3 minus ln 2 over root 3. And the tangent line is 1 over root 3x plus pi over 3 minus ln 2 over root 3. So it's just a little bit convoluted with calculations, but the procedure is always the same. Find the derivative. Once you have the derivative, find the y value if you need to, and then plug everything into y equal mx plus b to find b. You have m, you have b, plug those back in, and there you go. So this is the tangent line at ln 2 comma pi over 3. Done. So for the entire section, if you know the formulas, you'll be able to plug in functions to get where they go, and that's it. I hope you're not disappointed. Next class, we have entire class dedicated to a single section, which is word problems on related rates, and it's one of the most important sections, right, for your future, because that, as engineer, that's what you do, that's your job, not this stuff, because computers do this today. You plug in and get stuff. If you can't model, then you're technically useless on the market. So those are the jobs. So we'll deal with that tomorrow, and then we'll do some lab now. We'll do lab if we have time tomorrow after that lecture as well. And we can start slowly working on chapter 4. Now, we should discuss exam as well. Let me just end this. So, bye, stream.